8.8 Parametric Equations, Graphs, and Applications. We start with a definition of a plane curve. A plane curve is a set of points x, y, such that x is f of t and y is g of t. All that means is your x is a function and your y is a different function. So these equations are parametric equations with parameter t. Notice they both have variable t. An example looks like this. Let x equal t squared and y equal 2t plus 3 for t in the interval from -3 to 3. Graph the set of ordered pairs x, y. So at first glance, it looks kind of tough. And if you had to do it by hand, it'd be a little bit harder, but we're going to do Desmos. What you would do is you would make a table and take some t numbers like -3, -2, -1, and so on, and plug them into these variables. You'd get an x number, you'd get a y number, you'd get a whole bunch of x, y points, and you could plot those. Well, we're just going to do it on Desmos. So check it out. Notice x was t squared and y was 2t. Oops, that's -3. That's supposed to be +3. X is t squared and y is 2t plus 3. So I just make an ordered pair x, y out of those two equations, out of those two functions. You have to set the interval from -3 to 3 because that's what it's defined as, from -3 to 3, just like that. If you changed it, it's going to change what the graph looks like or how much graph is showing. So this is what's defined. We've got this graph. I'm just going to copy and paste it over because that's what it looks like. Example 2, find a rectangular equation for the plane curve defined as x equals t squared and y equals 2t plus 3. So it's the same numbers and everything, but they want a rectangular equation. Now remember, rectangular means x and y. So we want our equation to have x's and y's in them, but no t's. Here's what you're going to do. Take one of the two equations. It doesn't really matter which one, but usually one of them's easier. So pick the one that's easier to isolate the t variable. So we're going to isolate t. Let's subtract the 3 over, and then divide by 2, and that's what t equals. I'm going to take that t, and I'm going to plug it into the other equation. So you take that other equation, and you plug your t value, y minus 3 over 2, in for the t in that equation. Clean it up, simplify, and that's what you've got. Now, let's think about what that is. Well, if you had x equals y squared is a parabola. It's a sideways parabola. So notice if I have x equals y squared, that's a sideways parabola, and that's kind of what we have, but it's not quite right. Look at the vertex. The vertex is 0, 3. So in vertex form, you could think about it as x minus 0 and y minus 3 squared. Okay, that's better. Don't really need the minus 0. And this is way too narrow, so we would put a number in front of here maybe to change the thickness. 2, 3, that's making it too narrow. So maybe we have a fraction, 1/2, about 1/4. There we go, 1/4. That's it, that's the equation. And that's exactly what we have right here. X equals 1/4, y minus 3 squared. Graph the plane curve defined by x equals 2 sine t and y equals 3 cosine t for t in this interval. So again, a parametric equation, we've got an x function, we've got a y function. We just write it in Desmos as an ordered pair. So here was my x, 2 sine t. Here was my y. X was 2 sine t and y was 3 cosine t. And I've got the interval from 0 to 2 pi. So 0 to 2 pi. How you can get that symbol is typing pi, and Desmos just knows. So here we go. We've got a nice oval shape. Let's copy the drawing in there. Way too big. Give two parametric representations for the equation of the parabola y equals x minus 2 squared plus 1. So we want parametric representations. Parametric, we're going to have a parameter t. So this seems kind of weird, but what we're going to do to start, we're going to let x equal t. And we can kind of play around with this and do whatever we want, but we want to keep it simple, or I do anyway. You can make it a lot more complicated than this, but we're going to start with x equal t. So imagine if x equaled t. If x equaled t, then we could just put t into that equation, y equals t minus 2 squared plus 1. And our result, that's it. That's all we've got. That's our parametric representation. We've got an x equation, and we've got a y equation, or an x function and a y function. So we need two parametric representations. That's one. Let's do another one. So again, I'm going to keep it simple, t plus 2. And the more you do this, the more you kind of see what happens. You might be able to see what's going to happen. Something nice is going to happen. We don't have to use t plus 2, but that's just what I chose. So again, we said x was t plus 2, and we're going to take that and put it in place of the x in that y equation. If we have t plus 2 minus 2, those 2's are going to cancel out, and you're just left with t. So x equals t plus 2, and y equals t squared plus 1, because those 2's canceled out. That's all there is there.